In science, it's really important that you know how to graph and how to graph well, and that you can use those graphs. So I've got some instructions for you that's going to be important that you follow all year. When you're done with this podcast, you should be able to properly graph data and use that graph that you make to analyze data. You might be wondering why it's important for us to be able to graph. Well, a graph gives us a picture basically of the data that we've collected, and it makes it really easy for us to interpret that data and to predict more what might happen. We're going to practice making a graph. Now, here are the steps for graphing. The first thing you have to do is identify your variables. Know which is independent and which is dependent. Determine the range and the scale for our graph, or for our axes, and then number and label each axis. After that, we can plot the points, draw the graph, and title it. From there, we should be able to use our graph to analyze all of the data that we've collected or that we're looking at, and to make predictions. So here's a sample of some data that we can use to graph. Now remember, the first step was to identify the variables. We have to decide which of these, time and volume, is independent or manipulated, and which one's the dependent variable. The independent variable is the one that we control. We change it. Now, we didn't change time and we didn't change volume in an experiment, but we can determine, or we can decide how often we're going to collect data. So that's the time. So that makes time our independent variable. The volume of whatever this sample is changing over some amount of time. So that means that's the one that's responding to the time that's passed. So that makes volume our dependent variable. It depends on how much time has passed. So now that we've identified our independent and our dependent variables, we need to figure out where to put these on our graph. The independent variable is going to go on the x-axis, and the dependent variable is going to go on the y-axis. Remember, the x-axis is horizontal, the y-axis is the vertical. After we identify our variables and where they go on the graph, the next step is to figure out the range for our data. In order to do that, we subtract the lowest data value from the highest. So what that means, if I'm looking at my time right here, my highest value is 60, my lowest is 0. So the range for my independent variable, or the x-axis, is going to be 60. The range for my dependent variable, or the time, goes from a maximum of 300 milliliters all the way down to 60. So we take 300 and subtract 60, and we get a range of 240 milliliters. It's important to realize that it doesn't matter what the range of the time is when we're talking about volume, and it doesn't matter what the range for volume is when we're talking about time. We do these two ranges separately. After we determine the range for each variable, the next step is to figure out the scale, and that's basically how we're going to spread the numbers out on each axis. Now, depending on how big your graph space is and what your range is, that's going to help you determine what your scale might be. If your range was like 10,000, you may want to go up by 100, you might want to go up by thousands. Kind of depends on how big your space is. Since our range is 60 seconds for our independent variable, we might be able to go by 5s or by 10s, maybe even by 1s, but we wouldn't want to mark every line with a 1. Now our dependent variable is 240, so we would probably want to go up maybe 5s or 10s for that one too. We're going to have to look at our graphing space to be able to determine that. So let's look at our graphing space. Whenever you're making a graph, you should always use graph paper, and you should always make your graph take up as much of the space on that graph paper as possible. So remember we have time and volume for our variables. I've left the data table up here in the corner just as kind of a reminder of the data that we're going to be graphing. Now remember that our independent variable was time, and that's going to go on the horizontal axis. So that's going to go across the bottom here. So we're going to draw a line at some point across the bottom, and then our volume is going to go up the side. So remember our volume range was 240. We have to figure out how we're going to space that. Now remember I said I want to make sure that my scale stretches out across the graph paper as much as possible. So if we're looking across the bottom and we want to go up to 60 for time, if I go up by 5s for every one of these marks, I'm going to end up at 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. That would put the end of my graph right here. That is not taking up enough of the graph paper. So we have to rethink that scale a little bit. So instead, I can go up, skip a line, and make that 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and 60. So my graph would end here. Now it's not taking up the whole graph, but it's taking up quite a bit of space, so that looks pretty good. So now I'm going to go through and I'm going to label that. Now I don't have to mark every single line. I can skip for spacing. It makes it easier to read. So now that my horizontal axis is labeled, you'll notice I skipped some spaces. I didn't put the 5 marking, so I don't have 5 and 15 and 25 and so on. Now I can do the vertical axis. My vertical axis, remember the range for volume was 240 milliliters. So this graph could start at 0 because the lowest number is 60. But if you look at my line, I don't have enough room to start at 0. So I'm going to go up. I suppose I could if I wanted to squish things together, but I want to spread it out as much as possible. So I'm going to start the base at 60 milliliters. I'm going to go all the way up to 300 at the top. Remember, my range was 240, but my maximum number is 300. Now that I have numbers on both axes, the next step is for me to label those so that we know what these numbers are telling us. So remember that the bottom axis, the horizontal one, is time. I'll label the x-axis with time, and don't forget to include the unit of seconds, and the y-axis will say volume with the unit of milliliters. Alright, so I've labeled both axes, I have my numbers, I have the data that I can actually graph. The only other thing I need to do, besides actually graphing the data, is putting a title in there. So let's first plot each of our data points. When you're doing this, remember the x-axis value is on the bottom, the y is on the side. So if my first set of data is 0 seconds and 300 milliliters, I have to find that point on my graph and plot that point. So 0 seconds is right here. I'm going to go up to a volume of 300 milliliters, which is this top line up here, and I'm going to plot my first point on that spot. Now you'll notice my data point is actually kind of huge compared to this graph paper, but I just want to make sure you can see it. It can really just be a dot. That's okay. So the next one is 10 seconds. So I'm going to go over to 10 and up to 260. So I know this line is 250 and these others go up by 10, so 260 must be that one right there. Now I'm going to do that for the rest of my data points. Now that each data point is plotted, I am going to draw my line of best fit or best curve. In this case, it's a fairly straight line, so it's going to be a pretty easy line to draw. Sometimes you're going to have data points that are a little bit off of what you would call your line of best fit. In that case, you would just draw the best fit line possible. Sometimes basically you want to go through the center of as many points as possible and have an equal number on the bottom and the top. This one is going to be fairly straightforward. So we're just going to draw a straight line from the top to the bottom. Now you should use a ruler when you're doing this so that your line is actually straight. There we go. There's our line of best fit. So now we can use this graph to get some information. The last thing we have to do before we start to analyze data is put a title on our graph. When you're titling your graph, it doesn't need to be anything really creative and fluffy, like all you really need to have is the title of the x-axis versus y-axis. I don't care to know that it was the beautiful graph of the sunny day when the volume of the water tank decreased. I just need to know that it's time versus volume. If you want to say it's time versus volume for a leaking water tank or something like that, that would be fine, but all I really need is time versus volume. X-axis tidal versus y-axis tidal. It's pretty simple. The only other things you might need to include when you're graphing is some kind of key. If you're graphing two lines, like maybe the blue is this and the pink is this, or the dotted line and the solid line and what those mean. For the most part, this is going to be all you need. You can use a graph to get a lot of data. When you draw that line of best fit, you can interpolate and extrapolate information. Interpolating means that you are predicting data between 2 points that are actually measured on the graph. For example, this graph shows us that something had traveled 15 meters in 2 seconds and it had traveled 70 meters in 8 seconds. So interpolating means you're using information in between those 2 points, that line, to get other information. So we can interpolate that at about just after 4.5, maybe 4 3/4 seconds, this object had traveled about 43 meters. We didn't actually measure that, but we can use our graph to figure that out. Extrapolating data from a graph is similar. The difference is now we're extending our line beyond the points that we've actually measured to get some information. So here, our graph, our data stops right here at this point at about just after 6 seconds and a little over 50 meters. We can extend this line out past that data point when we use the line of best fit to extrapolate or get information beyond what we've measured. So we could extrapolate that in about 9.5 seconds, this object would have traveled about 80 meters. You're going to be doing a lot of graphing in science, so it's going to be really important that you know how to do it and how to do it well, and that you can read the graph after you make it. So if you have any questions, please come see me.